So, quick update. Two updates actually. A little bit closer to the moving day, and I don't remember how far we went along before I posted that video, but long story short, I have entirely moved everything software wise. I'm fully migrated onto this motherboard and 5 p.m. This motherboard chassis case configuration. I wonder if I can turn this around without doing it so slow. This is a motorized camera. There's got to be a way. One moment. Alright, back at it. So, this case has been great, although I will say, after I've gotten past the initial, wow factor of the case, I realize not that much of it is made of steel. It seems to be very different from the P600S, which was primarily steel and had some, other like glass accents. This, on the other hand, is primarily aluminum. It's split into thirds. You've got your aluminum front plate, rear plate, then the core chassis, which is just the middle divider, and then these structural components are steel, but these panels, they're plastic. I would have liked if they were aluminum too, but it's okay. Now, unfortunately, I did sit on this one. I heard a horrible crunch sound, but it seems fine. You can't tell. I did have some issues with this. I was running up to about 80 Celsius again, but that was PEBKEC. That was my fault. Taking this off, you will be able to see that I've put this up in here, put a little PWM fan splitter down here, nicely covered off. Also put in the SATA cables preemptively, so they would run to what I plan to do is have two SATA SSDs in here. Two SATA SSDs up front that I'll be scavenging from other parts, let's say. And that should be it for now. Also, I upgraded the speaker, so the PC speaker that's supposed to beep. They're generally really terrible build quality. They do the bare minimum of having like the piezo hooked up with two very low gauge wires, and I resoldered it, put some heat shrink around it so it wouldn't get the repeated flex wear of being bent back and forth and having the solder joint snap. But it's working pretty well now. I'm sitting at idle temps of mid 60s. Not fantastic, not great. Sound like Dyatlov. But this is good. This is fine. But another benefit that I didn't quite realize. You see, when I bought this motherboard, the plan was to have it be, an ITX machine. It would do the display using the 5700G as intended. So this motherboard has a pretty decent complement of two HDMI and one DisplayPort. Nothing particularly fancy, not the latest or anything. It's an X570 motherboard, so things like DisplayPort 1.2 or something. Regardless, it's fine. Now, the case seems to work a lot like a Faraday cage, which is a good thing, but also means that the second this headset antenna, if that'll focus, is... Oh. No, it won't focus. Okay, there you go. The second this headset antenna is too far behind the case, I lose signal integrity. It becomes very broken up, especially on my microphone side. It'll become broken up. Fine, whatever. I can work around that. But the hidden benefit from moving to this out of the 5900X system is that before, I have been encoding my video streams that I put onto Twitch. Don't forget to drop a follow on Twitch if you can also, and like and subscribe the video because I have no subscribers. You'll be part of my first 100. So now I have adapted my encoder in OBS to use the onboard encoder of the CPU. So the 5700G's gaming CPU does a pretty decent job for encoding H.264. Now the 5000X, I was pushing it a lot by trying to make it encode AV1, but that was mostly for my talking streams, so CPU wasn't already under a lot of utilization. So having this work for me in that regard, it's pretty good. It's a surprising benefit. I thought it was entirely a downgrade, but the core clock performance, it's somewhere between a 5800X and a 3800X. More than enough for gaming, and the fact that I can entirely offload rather than using NVENC to try and offload onto the another part of the GPU, I can offload it entirely, because as much as NVENC is great, it's not perfect. It does take a little bit of performance away, especially if you're on a 30 series card, which I am, and you're trying to play a game at the same time. So the devil's in the details, really, but I am looking forward to playing some more games when I have a proper cooler on board. Another thing that I didn't consider initially, but it's like one of the things that you cross that bridge when you get to it. When it comes to the fan layout, some people might think airflow, yada yada yada, up here, across there, but in truth, because it's mesh, I'm going to have every place I can play. Sorry, focus camera. Every place I can put a fan is going to be an intake, because it's mesh, and the fact that anywhere that I can put a fan, which is here, 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 is an intake, makes the entire mesh body an outtake, basically instantly pushing out the hot air. That's pretty good. Another thing, so this is very off topic and kind of pushes into my other personal hobby. All right, check this out. So this is the motor going back and forth. Just gotta wait for it to come around. Oh wait, no, that's the other way. Any minute now. Okay, so this pushes into my other personal hobby, which is just electronics in general. Maybe you could call it electronic engineering or something like that. I've been looking at solar, especially when you have a lot of, electronic gear in the house. It would really take the edge off on running powerful components and running so many displays, because I'm at the point where the monitors use between 40 and 50 watts each, and if I have 4 of them, I'm pulling damn near 200 watts just to view things. So what I wanted to do was to fully commit to the solar game. Now the problem with that is it looks nice at first, but being someone that likes to fully entrench myself into all that, when you get into it, it's almost perfect. It's great, but it could be better. If you're trying to, let's say, charge an electric vehicle, which would be like the end game when you're fully committed to generating your own power, you're looking at a very efficient conversion from DC on the solar side to AC on the consumption side. Then you look at it a little bit further and you realize just how many conversions you're actually doing. You're coming in as DC power from the solar panel, going to the inverter, coming out as DC for the batteries, unless you directly feed your appliances. But then in general, you want to store the energy in batteries. So then you go back into the inverter again as DC, come out as AC, and powers the components. But in the case of charging an electric vehicle, it gets even more complex. Now, I know that AC-DC conversions nowadays are very efficient, but it's stress on materials and generally unnecessary when the input and output should be the same. So you have DC from the panels, goes to inverter, becomes DC for the batteries pump back to the inverter, makes it into AC for the car's onboard charger. Car's onboard charger then makes it DC again for the batteries. It doesn't make sense. We can definitely do better than that. However, I've been doing a lot of research using a lot of modern search engines, which really are just AI. Google search seems to be, I don't want to say outdated for searching for things, but if you really want to troll through the internet for information, your best bet is to search with something like OpenAI's ChatGPT, or to use Perplexity AI, or Google's Gemini with deep research. So using all of those, I have had the worst luck trying to find anyone that does a DC to DC conversion for charging vehicles. It doesn't make sense to me. It basically means that all these car chargers, even the ones with off-grid capability, aka like charging from the grid, buffering that energy into battery packs, then charging the cars, it means they're all doing AC to DC, even when pulling from the batteries. I don't know, man. Doesn't seem efficient. But anyways, that's a bridge I'll cross when I get to it. Thanks for watching. Please subscribe, leave a like, just like here.